I would highly encourage all of you to go and check your grades in your grade books. So when you go into D2L, go to, let me see, Tools and Grades. You will see how you stack up this far as your grade is concerned. I'm not going to call names out, but there are 2 gentlemen in my class that are not passing this course. I will allow makeup work to be able to get that squared away. But do check your grades, because at the end of this week, ELW 110 will be over. And we'll be moving into ELW 111. And you can't recover from a course being closed. As soon as we get done with this one, we close it, and then we move on to the next one. So, Professor V, do you have anybody in that boat?
No, not failing, but they're kind of close to it. But it's,
yeah. Well, I'll just put it this way. A couple of you here are just missing a quiz, and that's putting you down in bad shape. So get in touch with me. Check your grades. Get in touch with me. We'll square away about getting those taken care of, and we'll get back on track. All right. So
I know I'm missing a quiz, but I didn't want to ask to redo it. If you're allowing it, I'd be more than happy to take it.
Sure. Why don't you not want to ask?
I mean, I didn't want to be that guy that missed it and then begging to make it up.
No, well, it's not begging. It's kind of looking at your work, seeing what you haven't completed, and contacting professor and being responsible. So I've got no problem with it. We've said that in orientation too. You guys keep track of your stuff. And if something's not going right, or you miss something, contact us back and get it square. I mean, I think you should know by now we're in the 3rd week, Professor B?
Mm-hmm.
Yeah, we are not, we don't throw down the hammer. So I mean, you go to some other colleges and you miss some stuff. The professor's going to say, well, you missed it, too bad. We're not that way. You'll find a lot of professors at our college that just actually give an extra one and drop the lowest one.
Yes.
Some drop 2. So all of you guys out there, if you see you're in bad shape or something's going on that you need help with, hey man, we're here. We'll help you out. We'll get you squared away. Even if it's one that you didn't do too well on. I go D and below. If you got a D or below on a quiz, contact us. The thing that you're going to have to do is keep track of your own work. I'm not going to sit day by day by day or week by week and go through everybody's grades, recontact you, you contact me. I want you guys to be responsible for your own stuff. So you see something that's not going right, you contact us. It shows me you got initiative and you want to be responsible, and then we'll square it away as far as it getting done. So Andrew, thanks for chiming in there. We'll talk later and I'll get you squared away. Okay, bud?
All right, thank you.
Yes, sir. Bricks Causey, yes, sir.
Can you show me which question I got wrong, like in a private message or whatever, later?
On what?
On the 3rd quiz.
Yes, sir. We'll do.
All right, thank you.
Mm-hmm.
I want to make one comment about that, if I could, sir.
Yes, sir.
You touched on this last week before, and it's okay. We're there. We're at our office on Fridays. So it's cool. If you need anything, just contact us. Text message, reminder, whatever. Please, I hate hearing my phone ding at 11:30 at night. Because I'm thinking I got to get up and go to work. I'm still in that mode a little bit, but yeah, just wait till the next day. Do it at 8 o'clock, a little bit earlier or something. We don't mind helping, but just not at all hours of the night, please. I've got a family too.
Yeah. Thank you very much. And I mean, I can't remember in orientation. What did we say? 6 o'clock?
6, yeah.
Yeah, 6 o'clock. Now, if an emergency comes up, I don't mind you texting me. And I mean, you might not get a reply. I think somebody texted me about a test at 3 in the morning. That ain't going to happen.
Yeah.
And 2 is, and you guys, I guarantee you start working for a utility, you're going to get this way. I only had a few that weren't when I worked with them. The phone goes off, and guess what? In 15 minutes, you're dressed and out the door.
Right.
You just kind of get in that mode of being called all the time to going on trouble calls and whatnot, and you leap and you head out. So, Professor V, thank you very much for bringing that up. I had forgotten about that. Okay, any other comments as far as that's concerned? Make up stuff and checking your stuff. All right, so if you'll notice in the books here, we are in ratios, unit 31, and you don't have to do this right here. The next one is proportion in the chapters and whatnot, and the representation of formulas. That's unit 34. General simple formulas, that's unit 36. And really, when we get into general simple formulas, that's Ohm's law, which we're doing already. We're using Ohm's law, and plugging in numbers, using that formula to come with an answer to whatever we need as far as power, volts, amps, and resistance. So we're really doing that now. Then we go into power formulas, which all they're doing here in the book is power, which we're doing right now. And then the last chapter here is, okay, I'm on page 215, section 9. Now, I'll ask you, you guys can give me an answer right here. How many linemen need to know trigonometry?
All of them.
0.
Guys, I've never used trig when I've worked even as an operations supervisor out there in the world. I never used trigonometry to do any kind of line work or line construction or even some kind of engineer work or working with math, doing computations and whatnot for whatever I needed to do. I will not do trigonometry out of this book. That's a disclaimer. Unless you want to. Who wants to? Go ahead and raise your hand. I didn't see any. All right, so you guys that have going on to the EET, you're on the EET path for the 2-year degree, trigonometry will be included. So here's the thing, you can't just go out there and say, well, I had trigonometry in section 9 of practical problems in mathematics, but Shoemaker didn't teach it to me. You're just gonna have to bone up and get your trigonometry done if you're in the EET courses later on. To me, as far as alignment is concerned, it's a huge waste of time. All right.
Why'd they make me take it then, Shoemaker?
So you've taken this course before?
Trigonometry I have.
Okay, but you haven't taken this course before, have you?
No.
Okay, so you're not going to use trigonometry in here.
Wasting my time.
I mean, I've got the questions ready. I'll go ahead and send you a test. You want a test?
No.
Oh, okay. Well, okay. All right. Now, last but not least from me, and then we're going to give you an idea of the week here because we're kind of looking at the weather. Today, it does look like, let's see, get on this one and get off that screen. Excuse me. Okay, y'all able to see that?
Yep.
All right. Looks like today, and we looked at the hourly right here. It looks like we're not going to get the chance of rain around 4 o'clock this afternoon is around 40%. We'll keep an eye on it. If we see lightning coming in or whatnot while we're out there in the yard, we'll shut it down. But today it looks like we're going to go ahead and do our D2, our Zoom here in the morning. I'll go out in the field this afternoon, get some more construction done. And then tomorrow, Wednesday, this does not look very good at all. So Wednesday is a 90% chance of thunderstorms. We will more than likely, unless something changes between now and then, go ahead and come in on Zoom. And then Professor V and I will have a D2L assignment in the afternoon, and we will let you know what that is. And when I say D2L assignment, it's not going to be out of this world or something hard. More likely a quiz or a couple question tests. Then Thursday, we got to just see what happens. Thursday is a 60% chance of rain, and Thursday night it goes down. So maybe in the afternoon we'll be okay with that as far as getting out there in the field. Guess what's happening this week? Guess what we're going to finish?
Test week.
This week.
Yes, sir.
Yes, sir. We're going to finish ELW 110. We're going to give an exam this week. Now, I've created these exams before, and I have to admit that the first couple of courses I taught about 5 years ago out there, what I did was a comprehensive exam. If you don't know what a comprehensive exam is, it's pretty much I take out questions that we've had on previous tests, put it on an exam, and then you complete that exam. So you see the exam come up. It's not anything that you haven't seen before. And you can actually go back on your test and see which ones you got right, see which ones you got wrong. And I heard that one person ask, what happened on that one. I'm not, for the past, Robbie, since you've been here, we give more of a scenario exam now. What I mean by scenario exam is you might get, and I'm thinking 4 questions. That's it. Of those 4 questions, there's multiple things to do inside of that question. So we'll discuss that a little bit later. It's not anything you haven't seen before. And we've done this for class before, and Professor Vermelin can attest to this. It's okay, depending on the hours, that if you jump into a test or quiz, and it's in the hours that we're working, we can come online with you and meet with you online, and you can ask a question about the question. Now, you're not going to get the answer, but we can rephrase. We can, I want to say, hints. We can ask you other questions that lead you into answering what the question is on the test, quiz, or exam. Is that correct, Professor V?
That is correct.
Yeah. It's kind of like a coaching thing. You're sitting in here, you're sharing your screen with us, you're on a test, and you look at this test, Professor Shoemaker, I've got to compute power here, but I forgot how to do it. Well, my first, input is going to be to you, well, what kind of formula do you need to use? Do you need to use Ohm's law? Oh, yeah, I forgot about the Ohm's law chart. Well, there you go. Then you're cruising on. Okay, I'll shut up. I've been talking a lot here. Professor V has got a quiz that is posted. Does it post up? Is it posted now?
It starts at 12, but I mean, we can back it up.
Oh, that's okay. That's okay. Starts at 12 today, and he's going to go over it with you. I'm going to shut my mouth and quit sharing. All right, Professor V, all you.
Okay, do you want me to give them some answers with that, or just let them guess? Can't hear you.
Sorry about that. Just have them work their way through it.
Okay.
Okay.
Okay. All right, gentlemen. Let me get back to my quiz. Give me a second. Tools, assignments, quizzes. And we're going to hit. All right, guys. Question number 1. Transformer primary voltage is 19.9 and the secondary voltage is 277. What is the ratio? Paul?
One second.
Okay.
It's like 1 to 71.8.
4. Yeah. Okay. 1 to 71.84. You remember how you got that?
Divide the primary by the secondary.
Correct. Okay. Anybody got any questions about that one? Okay. Moving on. Transformer primary voltage is 4,800. Secondary voltage is 480. Find the ratio. How many amps will be on the secondary side if there are 3 amps on the primary side?
Did you say 4,800?
4,800. Primary voltage is 4,800. Secondary voltage is 480. Say it again.
There'll be 30 amps on the secondary
How'd you come up with that?
because the ratio is 1 to 10, and there's 3 amps on top.
Okay, and so if we're going from top to bottom, what do we do? Multiply?
Yeah.
Okay. Okay, good job. Any guy got any questions about that? Okay, who answered that?
Briggs.
That's great.
Briggs. Should have. Okay, question 3. All right. A service has a voltage of 240 volts and the current is 62 amps. What size transformer is needed for this service? Paul, I see your little bars light up, but I can't hear you.
No, that's not me.
Oh, it's not you?
No.
Okay. Anybody? Okay, if you go back to your pie chart, I'll give you a hint. You're looking for watts, the power, kVA. So what do? P equals what?
E times I.
Okay. You got E and I in your question. Anybody?
What was the current again?
62 amps.
$14,880.
Okay. What size transformer would we need for that if you're looking at your chart? And out.
15 kVA.
15 kVA. Very good.
I jump in here real quick, V.
Yep.
If you don't have the chart, gentlemen, please let us know.
Yep.
The chart is going to be needed. And do this, Robbie. Just email it to me, and we'll post it in D2L today.
Okay. And I'll bring some copies too out at the field this afternoon if you need them.
The chart is going to be essential, gentlemen. If you don't have it, you're going to be hosed.
Okay. Anybody got any questions about that one? Cool. Moving on, number 4. Number 4 says primary voltage is 72. The transformer is a 50 kVA. What fuse size will this transformer need? Anybody?
You said 50 kVA, correct?
Correct. 7200 primary voltage with a 50 kVA.
Can I hear the whole question again?
You can. Primary voltage is 7200 and the transformer size is a 50 kVA. What size fuse will you need for this transformer? Anybody want to give it a shot?
$10 amp.
No.
8 amp.
How'd you get 10?
I was just guessing.
Yeah, good try, but no, that's not it. Does anybody know how to figure that?
7 amp.
Who said 7 amp?
I did.
Whose I did?
Cole Kennedy.
Cole, that is right. How'd you get that, Cole?
You
Well,
divide the 50 by the 7200.
50 or 50?
50,000
Correct.
by 7200.
Okay.
see, I did that, but I didn't think there was a 7 amp fuse because I ain't got my chart, so I just guessed.
Oh my goodness. Where's your chart at, brother?
In my vehicle.
Okay. Okay, ain't doing you no good right here, is it?
No.
All right. All right. 7 amp, and you divided 50,000 by 7,200.
Wouldn't you, question, wouldn't you want to get a bigger fuse for the, in case of overload?
And it's already, I mean, it's what's fuse, how much will that fuse go in overload?
If that fuse went into overload, it would be,
Isn't it like 10.5 amps?
yeah,
Right.
10.4, I think.
Right. So
Yeah, remember, if the transformer, it's built into the fuse companies and the transformer companies will work together.
That's correct.
Right.
All right. Just wanted to ask that, so.
you good, Paul?
Yep.
Next question. All right, primary voltage is 72, 7,200, secondary voltage is 240. Primary amps are 10. How many amps are on the secondary side?
300.
300. How'd you get that?
The ratio is 1 to 30, and 10 times 30 is 300.
Right. Guys, got any questions about that?
Nope.
Now's the time, gentlemen. If you didn't get that,
Yep.
want to know how we got to it. I mean,
Can we work out some of these together, like on paper or something or another?
Sure. Professor V is going to keep broadcasting here. Hold on one moment, and I will share a screen, and I will actually just draw down what the student, whatever student is saying as far as their equation is concerned, and you'll be able to see it on paper. Yeah. Hold on one moment.
Mhm.
Let's see here. Okay, we got to see a paint screen going on. All right.
I think you just locked on it, and then I thought it locked up, but it's good.
We're good?
Yep.
Okay. So go ahead with your question again, Professor V.
You want to do that one again, or do the?
Might as well. I think they were inquiring about it.
All right. Okay. 1 second. Okay. Primary voltage is 7,200. Secondary voltage is 240. Primary amps are 10. How many amps are on the secondary side?
Okay. And the student said he figured the ratio out here. So how'd you figure the ratio? Who was that?
7,200 divided by 240, which is 30.
Okay.
The
So
one,
30
the
of
one,
1 and
yeah.
3.
to 1.
And then you got to multiply 10 times 30, which is 300, and that gives you 300 amps.
Thank you very much. Fantastic. And this is being recorded, so it'll be shared on YouTube. All right, Professor V, you can carry on.
All right, let's go to the next one. Number 6. Question. How much in kVA will a kVA transformer do in short-term overload?
What size?
50 kVA.
75 kVA.
Okay. And how did you get to that computation?
50 times 1.5.
All right, so 50 times 1.5. And gentlemen, he took the 150% and just converted that to decimals. So what you do is move over 2 places, 1.5. And that equals
75
75.
kVA.
All right. Okay. I'm glad you said that after the question. I mean, it is the answer. If we're asking for a kVA answer, please do not forget to put
kVA.
kVA. Okay.
Can I tell you how I did it, just in case some of the guys don't do it that way?
Sure. Go ahead.
I did 50 equals 100%.
Uh-huh.
So 50% is 25.
So you're taking that 50% and you're saying half of 50 is 25.
25 and just add the two together. There you
and
go.
You get 75. Correct.
Instead of doing decimal places, just in case.
Okay.
That's how I do it.
Fantastic. Thank you, Paul.
Yep.
Any questions about that, guys? Okay. Moving right along. All right, next one is a 37.5 kVA transformer has an impedance of 2.6%. What is the true kVA of this transformer? Anybody? Anybody?
975. So
How did you-
97. That's 97.5 kVA.
Okay, how did you come to that solution?
All right, so 37.5 kVA is 37,500.
If
I
it has
divide
been,
it by, that's equal to 100%. So I divide it by 100 to get 1%. And then I times it by 2.6.
but how can the kVA be higher if there's an impedance? It would be lower.
I got 34 kVA, 34.5 kVA.
Okay, how did you come to your solution?
I did the same thing he did, but instead of
It's 975,
he
that's what it
didn't.
is.
Whenever you divided by 100, you didn't. All right. So what I did is I divided 34.5 divided by 100.
I believe it was
And
37
then
and a half.
after I did that,
It was 37.5
I got-
to start.
yeah, 37. My bad. 37.5
Okay.
divided by 100. Wait a minute. I might have.
Yeah, it seems
Yeah,
like
I did 37.5.
right. It seems like we're doing.
Oh,
and
no,
this-
I did it wrong. I did it wrong. I did it with 35.5.
There you go. Yeah, always look at what the questions ask you, and you'll see these written out. This is, we're doing it verbally right now, but you'll see these written out. And Paul,
Yes,
not to say, I mean, your method is your method.
yes.
On the 150% one, I like the way you do it. You take 100% as equal to the same number it is, and take half of it
Yep.
and then add it together. When I start getting into these decimals or percentages that are like this, I typically like to go 37,500, and this is me, times 0.0026. I convert this, 0.026.
So, Shoemaker, I got 36.525 kVA.
Okay, let me talk the rest of the way through it.
After I did it, I got the same.
37,500 times 0.026 is what?
975, I believe.
75. Now I'll just take this 975
And subtract.
and subtract it because it's impedance.
Yeah, I did the equation wrong, but I had the right
Taking it
thinking.
away. And let's see, 10 from 5 is 5, 9 from 7 is 2, 14 from 9 is 5, 6.
Yeah, my bad.
No problem, no
I
problem.
just work in percentages because I take it to the whole number.
Yeah,
It's just easier to work in my head than on a calculator, that's all.
that's fine. I mean, that's cool. That's, we talk about math before. There's more than one way to skin a cat. Whatever, whatever works for you works for you.
Yeah.
That's the route that I take out there. So is anybody else got any questions of how that works? Remember, impedance takes away. Okay. Professor V.
Load. And okay, here we go again. Secondary voltage is 240. Amps are 212. What size transformer is needed?
Oh, we need Ohm's law, don't we?
Yes.
Okay.
You have to have a P.
All right. How do I mean, I threw that right away before. I really should let you guys answer that. How do I know that I need Ohm's law? He's giving you a voltage, he's giving you an amperage, and he's looking for a wattage. So you ought to see by the question that he's given out here. He's given me two different items of Ohm's law, and he's asking for the third. So P equals, now you got to go to your Ohm's law chart.
50 kVA.
All right, how did you compute? What is the Ohm's law?
Ohm's law is P equals E times I. So it's
Times I, that's no problem. E times I.
equals volts times.
So you took 240, you plugged the numbers in. You took 240 times 212.
Equals 5880.
Oh, so 5880. So that's power in watts. Professor V,
Yes.
did you ask for KVA?
I don't know. What size transformer is needed?
Yeah, okay. So 1, 2, 3, a 50 point, really, 8. There's no such thing, so you're going to refer back to your chart. Mr. Paul was right, 50 kVA. All right, I'm ready for the next one.
Okay. All right. What is the fuse amp value for a 65 amp fuse in overload?
What's the math behind it? Anybody?
What do you say?
Is that 97.5?
State your question again there, Mr. V.
I'll state it one more time. What is the fuse amp value for a 65 amp fuse in overload?
It's like 97.5, I believe.
How did you come to that solution?
I've been saying that for 5 minutes. I thought I had my volume on, but I hadn't
Yeah,
muted.
I heard you to start with. You're good to go.
65 times 1.5.
1.5, so you took 150% and you converted it to decimal. 65 times 1.5. All right, make sure you put your symbol down. 97.5. Okay. Thank you, sir.
Questions? Okay. Last one. Okay. A residential customer has its thermostat set to 70 degrees year round. That's winter, summer. Winter temps average 35 degrees and summer temps average 90 degrees. Hang on. This is true or false. The summer temps are harder on the electrical system than are the winter temps.
False.
Oops, 70, excuse me, 70.
What did you say the temperatures were again? I know it's 70 on the
70
thermostat.
inside, 35 winter, 90 summer.
Yeah, it would be false.
Why is that?
Because it's got to make up more in the wintertime.
Okay.
35. No, it's 40, 55 in the wintertime and only 20 in summer.
There you go. I'm drawing it out as you're speaking it right here. So you took his normal thermostat number, which is 70, and subtracted it from 90. You got 20 degrees. And you took your normal thermostat number of 70 and subtracted it from 35 and got, excuse me, wow, that's way off the mark. 35 degrees.
Oh, that looked like a 90 in front of it. My bad.
Okay.
Yep.
So whichever temperature is more severe is the one that's going to be tougher on the system.
Okay. Guys got any questions about that or any of the other questions? No? Okay. And I want to just add a comment about that question number 10. As some an experience I had, you know, pulling call over the years, especially in the winter, I've been out and seen, you know, like in an old system, old part of town, and open wire secondaries. I mean, when I got there, the transformer was off. It was hot, so I reset it, got it back on, and I could just sit there and watch them. It looked like a little heater coil and a little small heater, the element. I mean, they just turn cherry red and start to sag down. I mean, it is that hard on the system, and it just pulls a lot of current because most of those folks are having those little electric heaters, and it just cooking the system. So
yeah, yeah, I've seen pad mount transformers in subdivisions, even after, you know, you've had a good snow and ice.
yeah,
Around the transformer itself, the ground is dry. It's melted all the snow off. The ground is dry and actually so red hot that you can see the core of the transformer through the metal tank. It gets extremely, extremely hot.
it does.
Okay.
That's all the questions.
All right. Any other questions on the questions? One point I do want to bring up before, let me get the share stopped. One point I do want to bring up before we take a break here is, Mr. Stats, is all of our sessions here are recorded. Where did everybody go?
Took a break.
I guess. Is that our sessions here are recorded, and it's kind of, you know, surprising. I can see how many people, I can't tell who, I can see how many people have gone to and looked at the videos after we have done the class. And sometimes they're extremely high. Sometimes I only get 4 or 5 hits on a video. Guys, to be honest with you, if you go back on a video, you got the answers. You got the answers now. There is an option, and if you want to do this yourself, there is an option on your phones, PCs, whatever you're using out there, that you can record me now and just save it yourself. But I like using the YouTube because you can just come back and reference it. So use those resources if you need them. One thing that does kind of get Professor Vermelin and I don't want to say mad, just kind of disrupted is if we go over something and we have to go over it 4 or 5 or 6 times with multiple students, we'd be sitting here all day long. Use the resources that you have to do your study and your work. And if you've exhausted everything out there that we're providing to you, by all means, go ahead and ask us a question. This is going to be the same thing that happens to you guys out there in the world. You're going to get, and Professor V, before we take the break here, Professor V, I don't know what kind of progression checks that you used in your organization as far as Duke is concerned. You can chime in here as soon as I get done. But what we assigned every new employee, what they call it, was a progression manual. And coming into a company as a groundman or a line technician C, in that manual, which you kept, you can keep it in a locker or keep it in your truck or the service center, there's a checklist of things that need to be completed. Now, that doesn't mean you can go in there and say, well, make up a cross arm. You can't check it off yourself. Yeah, I did that, and check it off yourself. You have to make up a cross arm proficiently. You have to do it well within a certain amount of time. Then your supervisor is going to say, yep, let's go ahead and check that off. You're going to get instruction You're going to do it a couple times, but people are going to start questioning, hey, you know, we've taught how to make a cross arm up probably about 5 or 6 times. And consistently, you either need to ask how to make it up, or you've got something wrong in the process. Things are starting to go downhill a little bit, if you want to put it that way. So you guys use all the resources that you have. I think Professor V and I, as far as doing that, are doing rather well. If you don't think we're doing rather well, please, we're open to suggestions.
Yeah.
But use those things that you had. As far as progression, and when I say progression manual, it's all the way through line technician A. So once you've completed that manual, which takes about 4 to 5 years, depending on your organization, you're ready to become in the supervisor level. Professor V, did you have anything of that nature?
Yeah, they did. At Duke, the supervisor has a checklist, the same thing the employee has. But being that the supervisor's not on all the jobs, usually we had what we call a crew lead. And the crew lead would actually, the supervisor would tell him, say, look, this is the things he needs checked off on his list. Watch for him, work with him. And he would, out on the job, watch him on some of the tasks he had to do. Sometimes the supervisor would need to be there for certain items that needed to be checked off. But if not, then the lead lineman and the crew member who needed it checked off would get together and they check it off and then go sit with the supervisor and check it off the supervisor's list.
There you go. There you go.
Yeah.
I do know you do this is typical, and we'll talk progression links is whatnot. The typical one for Santee Cooper was if you go into an organization as a line technician C, you're in there for at least 1 year. 1 year as a line technician C, you're checking stuff out of your progression manual in this line technician C area, and you're going to be tested, right? It's both a written and a hands-on test. That is at the discretion of the supervisor. Now, the supervisor can say, this is rare. I've got a crackerjack guy here. He's doing really well. He went to Horry Georgetown Tech. He knew a good bit of stuff when he came into the organization. He has the authority to put you in 3 months early. So actually after 9 months, if he feels really confident, he can put you in 3 months early. Or you can put you in the year. Now here's the flip side. If you're not doing too well, he can extend. So he can extend another 3 months past your year before he lines up the test for you. I will guarantee you this. Part of it has to do with the supervisor himself. If he is supervising you for a year and he sends you over to get that test, he's not doing that. Another area or a unit of employees is going to test you, and a trainer. So there's no favoritism going on there. He's not going to send somebody over that's kind of sketchy and give him the test, because if he doesn't pass that test, both the hands-on and the written part, where does the blame really go?
The supervisor.
Right. That supervisor didn't prepare that employee well enough, and both with his crew members and himself, for that guy to take the test. The supervisor wants to shine just as much as he wants that employee to shine. So they're not going to send you unprepared for those courses, or for those tests. Okay, gentlemen, I am showing 10 o'clock. Let's return here at 10:15. Let's go ahead and take a break. Professor V, if you could keep an eye on the time for me.
Okay.
So we should be getting the equipment in within the next probably 2 or 3 weeks.
I don't work for Jay Harlan. If you want to, who was that?
That was cold.
Cole Templeton. Well, guess what? I'm going to do with you just like I did with the last class who asked that question. You're going to be our representative for both classes in communicating with Mark Jones to see how progress is going along.
Tenfold.
So if you could email him, and then when we have class tomorrow, when he emails back, give us an update of how things are going.
Sounds good.
That way he's not getting bombarded and we're getting information.
All right.
I wish there was a little something that had like a stand. Is there a stand on your tablet, on your Wacom?
It's got the little legs that fold out.
Ooh, here we go. Yes, sir. Here we go. Yeah. All right. Hey. Now we're cooking with gas.
Yeah. All right.
Okay, gentlemen, I am showing 10:15, so we'll restart back here. A common, I'll go ahead and say a problem that usually occurs when we start getting into these tests, quizzes, and exams about doing these computations is, when do I need to use Ohm's law? And when do I need to use the ratio? And you might see some questions come up, whereas I need to use the ratio and Ohm's law together. So some little hints here to help you out in those processes. When you have a question, and Professor V, I don't know if you have your questions up still.
Yeah.
Could you give me an example of an Ohm's law question, please?
All right. Do it. And all right. All right, a service has a voltage of 240 volts. The current is 62 amps. No, yeah. What transformer is needed for this service?
Okay. And it goes into the wording that is putting out there. And when he talks transformer, he's looking for a kVA size. And we've talked about this before when we talk kVA, loosely for alignment that concerns wattage. So whenever you have a problem that has two different values, and he's looking for the third value, I've got voltage, I've got amperage, and I'm looking for the third value of wattage, that's when I need to go to Ohm's law's chart. I've got three different things here, and I'm looking for this third of the power. That's where I go into Ohm's law. So just go back to your Ohm's law chart, find out what the computation is. I think that's a multiply. E times I equals P. Just plug the numbers in. 240 times 62 equals the solution. So that's when you use Ohm's law. Three different values, two are given. And like I said before, if you run into a question where you don't have two given values, it can't be computed. We're giving you those two, 240 and 62, and looking for the third, power. That's when Ohm's law is needed. All right, Professor V, a ratio question, please.
Ratio. Okay. Ratio. Transformer primary voltage is 19.9. Secondary voltage is 277. What's the ratio?
Secondary. And I don't know if you guys are doing it out here. I still do it today. I've got a sheet of paper over here when Professor V is doing the questions and I'm not using the screen or whatnot. And I just write them out in this fashion, just the way I'm not drawing the transformer in. You can if you want to. I'm just putting the voltage, the primaries on top, the secondaries on the bottom, and I'm just drawing them out on a piece of paper. All right. And what was the rest of your question? The voltages were this and the rest?
Yep. What's your ratio?
What is the ratio? That's all he's asking for, period.
Yep, on that one.
All right. So all we have to do here is divide 19,900 by 277. That gives our solution. Now I'm going to expand on this one a little bit, just a little bit more, and use that same problem. I want to go to the 19,900 and the 277 like he gave us before. All right, now I'm going to throw in there, I have 10 amps here. And I'm looking for amps again. Now this is where it kind of changes. I know I need to provide a ratio, and I'm not looking for something different than amps. I'm looking for amps again.
You need the ratio to times it by.
You need the ratio to be able to do that. I'm not doing a 1 voltage, a 2 amps to a 3 power, or any of the combinations thereof. I'm looking for an amp value that is given and an amp value I need to compute. These stay the same. So Paul had it hit it right there on the head. He had to figure the ratio. Go ahead and figure it for me, Paul. What is 19,900 divided by 270?
71.84.
71.84. That always, the larger number, gentlemen, always goes at the bottom to 1. All right, remember all this right here because I need to get more space. No, don't save. 19,900. 277. I had 10A here. It's gonna be given in the question. 1 to 71.84, correct?
Yes.
Whenever I have the top number and I'm going down, it's multiplied.
Yes.
All right. Same question. Geez, I cannot write. All right. If I give you the number at the bottom in the question, and I need to compute to find this number at the top, both are in amp values, it's divide. Go in this direction, up, to find that value, it's divide. So I'm going to take 512 and divide it by 71.84 in your calculators. Top value down, multiply. Bottom value up, divide. Any questions there? Okay. Hope that helps you in your computations. All right. So we'll talk a little bit, and not to freak you guys out here, we're looking at the weather closely. I am probably going to go ahead and develop the exam today. You might see it tomorrow. If we'll have a Zoom class in the morning to review it. And if it's raining tomorrow afternoon, I might go ahead and assign it. And if we get that exam cleaned up and done for everybody tomorrow afternoon, not to put the strain and stress on everybody of trying to get it done in a decent amount of time, we'll get plenty of time to do it. And Thursday is clear. Professor V, double check with you on this. We'll go Thursday all day.
All day.
At the field.
Heck yeah.
So I don't want to, there's 34 of you out there. I don't want to put the pressure on because I know some of you are working or whatnot. So if you have a problem with that, do let me know. We'll leave the exam open through Thursday to be completed. But that is the initial plan right now with the way the weather is looking. So just as an example, and what we'll do here is I'll take about 10, maybe 15 more minutes to give you an example or an idea of what an exam question is going to look like. And then we will go ahead and excuse the ones that don't have grade problems. Don't everybody leave at once, because I need to chat with a couple people in here, and then we'll work those things out probably up to 11 o'clock and then head out to the field. So give you an example here of, what we're trying to do in this process is throw you into the real life scenario. You're going to step onto a job site, you're going to run into something, or you're just going to build something from scratch, brand new, and you're going to have to do some computations to figure things out in the real world. So a good one would be, and it might not be this exact question. Okay, I have a sporting complex. Okay, my concession stand uses 5,000 watts. All right, the ball field lighting equals 20,000 watts. They have a water sprinkling system. That's another 4,000 watts. Okay, my location is Maine. Average temp, 70 degrees. Average temp, that's through the full year. I know, and put this into your brain cells right now, you know it can get down to the 1, 0, and negative degree values here in Maine. What size transformer am I going to install? Simplicity right here would tell me I need a 5,000, 25,000, 29,000 watts. Okay. I'm assuming right off the bat, I could probably go with a 25 kVA, because a 25 kVA will do what in overload?
37.5.
37.5, right. That's at 50%. Where are these temperatures going to go in the wintertime?
They're going to drop.
They're going to drop severely.
Yeah.
Is that 37.5 going to be able to handle this wattage when it's -5 outside?
No.
Okay, so what transformer are you going to go to?
40 kVA.
All right.
Oh, 30 kVA. Sorry, 30.
What was it?
A 30 kVA.
No, is that on your chart?
37.5 kVA.
I'm reading the wrong one. Sorry, I was reading the amp one. Yeah, 37.5.
Right. I'm going to go ahead to the 37.5 and install it. That is going to be my answer. So you got, not only do you have to factor your total wattage, right, to get to your transformer, you also got to factor, well, where am I? All right. The rest of the questions are going to be similar. And what's going on here is you're computing not only what the wattage is and what you need to do, you're computing where you're at. You got to use a little bit of brain cell matter to get out there. Well, I'd rather be safe than sorry and go to a 37.5 kVA than have to come change that back out. Now the question's not finished. All right. What size fuse do I put in that transformer?
You need to find the voltage, correct? To find the ratio.
Right, right. So we're going to have that information, right?
Right.
Right. It's set. You're going to have a primary voltage, 7,200 volts. So now I've got power, and I've got voltage, and I'm looking for I. So what fuse size do I need? $37,500 divided by 7,200.
5.2.
5.2. Go by your chart. This is why you guys need to have this chart. It's essential, very important. It's essential. What size fuse I'm going to put in it?
5.
A 5. Okay, that's all wrapped up in one question. And you're going to get 3 questions somewhat similar to this one and 1 safety question. All right. Any questions that we have as far as what you're going to be having in expectation of coming up on the exam? It's fairly simplistic. I like the more application-based one. We're not just going to throw, you know, what's 4 times 6 equals what. I want you guys to put your brains to work in the environment that you're working in and be able to not only, one, this is an install, is not only know what you need to install at a location, depending on what they have, is to also troubleshoot. And that'll be wrapped up in the question also. Part of one of those questions, a good example would be, you could drive up to a transformer that's feeding 4 homes, and you notice that the paint has been peeling off the transformer and it's extremely hot. What do you think you need to measure first? Does voltage matter? Yet. What's making the transformer hot?
Too much power is being used in all the homes.
Yeah, too much power is being used, but the measurement you're going to take, we don't have a watt meter, but what we have an amp meter. All right, where are we going to find the voltage at on the transformer? Where do we find that information? On the nameplate. So you can have an expectations. I'm going to include the picture of the nameplate of a transformer. Then you've got to find to solve what the problem is. All right. Sounds like everybody's kind of confident out there. I don't have any questions. Have you heard any, Professor B?
Nope.
Okay.
I got a question, but it's not really about that right there.
All right. Well, hold on one moment. Let me get a clear screen. Go ahead, sir.
It's more on the lines of how do you label the 110? That do you consider those different courses, or how's that go?
Yeah, the ELW 110.
Yeah, which course would you say would be probably the hardest one out of all the courses?
Out of all the courses, Professor V, I'm probably going to go with 112.
Yeah.
112 as far as the learning properties and whatnot. As far as book work, is that one. Depends on how good a climber you are also. I mean, 114 can get difficult for some people.
Yeah.
To be honest with you, I mean, the prerequisites for the courses and whatnot are not extremely high. We teach you in the fashion, and you know, it does bring something up and remind me to show them the next book, Professor V, of, you know, Professor Vermelin and both I have the mind concept, and so does the college. I think my department chair and our dean agree 100% on this. We can book learn you and go by the book, rule by rule, step by step, and you guys would have great technical knowledge. We can deviate, which we've deviated a good bit from the practical problems in mathematics, and we can teach you what Lyman do. I like the part where we're teaching you what Lyman do.
Right.
You know, practicality. We want you, and this is our goal. This is how we get paid, is that when you graduate from this class a year from now, we're going to recontact you and ask you where you're at. Are you placed at a utility? Are you any utility? Or are you working in a similar environment where you're using these courses to get a career? We get that percentage back, and that percentage right now is sitting at 92%. 92% of the students that I've had for the past 5 years are working in a career related to the utility industry, or not, you know, or in the utility industry itself, which is rather good. So that's how we know that we're doing the right job. I like the practical side of it, and I'm kind of a K-I-S-S guy. Keep it short and simple. Okay. Does that answer your question?
Yes, sir.
Okay. Okay. Yeah. I mean, Professor V has probably seen them. He's seen guys walk into his company and they come, you know, strutting with that nice hairdo and the beard grown out, and they're all nice fit and trim, and you know, they think they rule the world. I don't mind you guys having confidence in yourself, but be humble.
Yep.
Yeah, be humble, and don't try to talk over people. It is good though, and I've heard many comments. Many comments have come back from supervisors of crews and managers of companies to where, and I'll give you one example here, where they have graduated from my class, gone out first day now, stepped out on a job, and be able to take a piece of equipment, locate an underground fault, dig it up, splice it, walk away, all by themselves. You'll be able to do that.
Yep.
And that's where we need to have you at as far as, you know, your careers are concerned. That's what the employer wants. Guys, take a guess of how much it takes to train a newly hired employee with no experience, just to get them in the door and put them on a job site.
Talking weeks or what kind of time frame?
I'm talking money.
How much?
How much?
I have no idea.
$8 grand.
All right.
30,000.
The typical one for typical companies, I would say named companies like Ori Electric, Santee Cooper, Duke Energy, it takes right around $56,000. That's the average. How much does that company have to spend when you enter the program, when you enter their company?
Not much if you know what you're doing.
Probably about $1,200. And the reason is they need to teach you CPR and first aid inside the company before you get started. That's it. All right. Now, I heard the question come out there, how long? Who asked that?
I asked because I didn't know if you were asking time frame or money frame.
Yeah, that's all right. I want to get to it. That's a good question. It typically takes 3 to 4 weeks before that employee can step onto a job site and start work. How long will it take you?
Not long, because I know I talked to some of the guys out there at Ori Electric, because that's where I was going to try to get on with, and they were talking about if you get hired on out there, you're going to start out like how you were talking about. You got to have that book you complete over a certain amount of time, but they said after you're there, I think it's, with Ori Electric, I think it's 9 months, then they start sending you to a week-long class in like Columbia.
No. I'm talking about stepping out onto a job site and just going to work. It doesn't matter if you're picking up trash, whatever.
Picking up trash, if you don't know how to do that, it shouldn't be long.
There you go. They're going to give you a CPR training and a first aid training, and you'll be able to ready to go to work in 8 hours.
Bam.
Where this guy is sitting here 3 to 4 weeks. All right. That's part of this cost right here. That's the money lost from you sitting in class and not being on a job site, plus the amount of time it takes to train you and the resources to train you. That's how much money is being lost and spent. You would not believe that when your company is hiring, let's say 4 employees at one time, that counts? That's $250,000. That's why we get you prepared to step onto a job site and go straight to work. Okay. Professor P, anything you'd like to add there?
Nope. That sounded good.
Okay. Yeah, I mean, and I'll be totally 100% honest here. I'm not going to talk about other colleges hard, but I will give you some examples. In working with Santee Cooper, we hired from Trident Technical College for 3 years, and I have to admit, the guys coming out of there looked like true linemen. But and here's kind of part of the problem. Most of them can climb like squirrels, climb a pole, do things up a pole, have great, things as far as construction, both in the overhead and underground portion. And then you tell them, hey, I need to load up, or you know, you got a scenario here where I need to know what size transformer I need to put in, and they go, I don't know how to do that. Or what does a reel of 1/0 triplex look like? Well, I don't know. You know, it's kind of one of those things. You need to know the basics, because the first thing in the morning, who's going to be getting the material and putting it on the truck?
You are.
You are. Okay. I would scratch my head, and my supervisors would, you know, be jumping all over my back. Why in the world did we hire this guy? And he gave me, I'll just give you one more example. I'll probably have to bring it up in a share. We sent a guy out to the yard to load a reel of 1/0 triplex. Well, triplex, tri, means there's 3 wires. How do you think he'd be able to determine what size he needs? Just determine it. A reel, correct? Well, what do you think's written on the reel?
1/0 triplex.
Exactly. 1/0 TP. What do you think is written on the wire?
1-0.
There you go. 1/0 TP. It losses a football bat. Okay, hold on one second. I'll give you a funny one here, and then we'll turn it loose for the day. You cannot minimize.
Professor,
Yes, sir.
did you and Professor, did y'all both do distribution and transmission, or?
I did distribution and transmission training, and we actually had to do, in our company, all the linemen had to do 1 year of transmission.
Now, did you like transmission better or distribution?
They're pretty much both the same. I have to admit, transmission was a bit of a challenge as far as moving from, you know, working on a 40-foot pole with rubber gloves to working on a 200-foot steel structure with sticks. That's a different scenario. The thing that kind of, and this, it's a good question here, because today, and this was me, I'll just give you my life story right here, real quick. I was married, had 1 child on the way, liked the Myrtle Beach area. I went the distribution route because I didn't want to go and have to move all over the state. If I was single and wanted to have all my travel paid for and travel the state and sometimes go out of state, I probably would have gone for transmission. But I had some responsibilities going on there, so I kind of wanted to stay local. Does that make sense?
So like the big companies, do they usually go out of state, or they usually just contract it out most of the time?
It depends on the company. I know, and Professor B, I'm going to let you jump in here. Santee Cooper does contract a lot of their work. They don't contract any of their transmission work. They contract a good bit of their distribution work. When you're talking about going out of state, depends on, well, this would be a good one for Duke. Santee Cooper does not go out of state unless it's a storm situation.
Mm-hmm.
That's because it's a state entity.
Yeah.
Now, if you get called out on a storm, you can go to, well, I mean, crews went to Puerto Rico. I've been to Florida, New York. I've been all over the freaking place. Now, Robbie, Professor V, as far as Duke is concerned, their territory is huge. What do they do?
Sometimes they go and assist, especially if transmission crews. They may go up to Ohio, Kentucky, Indiana, and work, or they may go down to Florida and work with Duke crews down there. But normally we stay in our own zones. As far as cross-training transmission and distribution, you're a distribution lineman or a transmission lineman. You could go, if you wanted to go work on a transmission crew, you had to apply for a job there. You just couldn't jump back and forth. You're either transmission or distribution. Some guys wanted to go to transmission, so they go work transmission. They decided, hey, that wasn't for them, and they'd wait for an opening in the back end area, and they'd come back to distribution. It depends on what you want to do. At Duke, things are kind of different from anywhere else. You're either a transmission lineman, distribution lineman, engineer, some kind of executive representative or something. they kind of bundle everybody into their little groups, and you kind of stay in your little group. That's the way Duke likes it. So it's different.
Yeah.
What's the big difference between transmission and distribution?
Everything's bigger.
Size matters.
Size matters, yeah, at least to them. You're not going to be rubber gloving much stuff. It has a lot more to do with stick work, where you're able to actually, and we'll show some of it here later on, you're actually able to untie and tie conductors with sticks and raise them and lower them and build structures with sticks. And they actually have wrenches that go on the end of sticks. There's no rubber glove big enough to insulate you from transmission voltages, so it's all stick work. Yeah, I mean, we're working with an insulator on our crossarm that weighs what, Robbie, 3 pounds?
Yeah.
Transmission, you might be looking at 200-300 pounds.
Yeah.
On a set of insulators for them. So you gotta have a lot of different rigging, and equipment you're going to be using also. Robbie does bring something up also that I saw in some employees that came into our organization. Don't job hop. You know what job hopping is?
Yeah. Go from job to
Well, you
job.
start out in distribution, you work for distribution a couple of years. I kind of want to go to transmission. Well, you went to transmission, you worked for transmission for a year. I don't really like that. I want to come back to distribution. For one thing, people are not too, once I get somebody in my service center and in my area that's working with me that I like, and I'm training and I'm getting progressing up the ladder, I really don't like if they go back and forth, back and forth, back and forth. It just kind of muddies the water for me, and it muddies the water for a lot of supervisors like that. Another thing that happens in this organization, and I don't know if this happened with Professor V's, is if you go in as say you're a line technician A in distribution, and you go to transmission, they're going to bring you in as a B. Okay, so you're going to have a pay cut. Now that's only going to last for 6 months until they reevaluate you for a transmission A. So you did that. I was a distribution line technician A. I went in as transmission as a line technician B, served 6 months. Now I'm a transmission A. I served a year. Now I want to go back to distribution. Well, guess where you go? Distribution B for 6 months. So every time you do that, you're kind of shooting yourself in the foot.
Mm-hmm.
What's the different setup as far as, I know, like you said, when you go to transmission, you on sticks. So how's your climbing set up as far as safety wise?
Same kind of safety gear as far as that's concerned. You will get a different size buck squeeze that fits a bigger girth pole.
So basically you're using the same type of buck squeeze, but instead of going around the pole, you're just going right above the sticks and using that as your fall support.
Yeah, here, hold on 1 second, and I'll get a video going on here that shows you a good example of some guys working transmission. Stand by. Good questions, guys. All right, let me get this over here. Get this one started.
And let's go right to the radar. You can see the
Okay. Go to share screen. Y'all see that screen?
Yep.
All right, here we go.
activity moving to the north. Look at that now.
How old do you think that truck is?
20 years.
Brand new.
Yeah, that truck's 4 years old. They love to take care of their fleets.
Kind of feel like a hero sometimes. Just the power goes out, you know, you leave your family.
So Joshua Mackey, he's visited the field a good bit before. You'll probably see him again there. But he's
Hey, I
in.
know that guy.
Congratulations. So this is distribution work. He's climbing a pole. He's up at the neutral here, but you can tell by his work, the proximity. He's got a rubber hose on here, which you need to hose up all conductors, and he's wearing rubber gloves. But you're able to work in distribution right next to it with protection. Fire retardant shirt, Z87.1 glasses and hard hat. Shouldn't have those stickers on it right there. Fire retardant vest and rubber gloves. This is distribution.
And go out there and help get the stuff back on. Well, when they first gave me that uniform, I was too yes.
Green's froze.
We're Sam.
What? Freeze frame?
Nope, never mind.
Sure, for sure. I mean, that's kind of, that's the big thing around here.
So you can see here, I mean, look at the proximity. This is 7,200 volts. It's got rubber gloves on. It's got rubber sleeves on, rubber hoses on the conductor. But I mean, essentially, you're within, you see his face to here, you're within 2 to 3 feet and sometimes even closer as far as working in proximity to the voltage distribution.
It takes a special person for the job, a person that's willing to give 100% most of all, a person that's willing to be a team player, a person that got common sense. This is the job to have. It's a little dangerous, but it's what you make of it.
Okay, I want you to watch closely here, and I'm going to change this to slow motion. About half speed right here. This is 7,200 volts. What they're doing here is they're moving this conductor over to the new pole. I want you to see how close they get it to the top of the pole right here. You should not make contact with anything else. I'm guesstimating right about in that area, he's got about 2 or 3 inches. All right, both of them are keeping an eye on it. They're watching it close. But you have about 2 or 3 inches of clearance to that wooden pole. In distribution, it's okay. That cannot be done in transmission. It's way too close.
Gotta be able to climb. Can't be scared of heights or electricity. You really have to respect it.
All right, guys, just to give you an idea here, this is not a stage show. They're not climbing just because they want to do a video on climbing. This is a 5-person crew. 2 people climbing, 1 people in the bucket truck, 1 person in the bucket truck, and 2 guys on the ground.
I really don't consider myself to be very athletic. I'm pretty active. It's a lot of physical exertion, and it gets hot. You do have to have some kind of stamina to be able to hang with it. The job is very dangerous, especially like during storms or something. You're working with high voltage, 7,200 volts, basically all the time. Just always got to keep a clear head, So, yeah, it's dangerous. There's a good bit of training that goes on for this. They give classes all through your first 5 years. It's constant.
Make a mistake, it might be something you got to live with the rest of your life, or injure you, people you work with, injure yourself. In the summertime, it's hot, sweat, and you up the pole doing something. The heat can hurt you. In the wintertime, it's cold, freezing. You just have to be able to handle the extremes of the weather.
You see how fast he's climbing? You guys are looking like that.
I feel it's real important in my community. Lights go out, especially in the wintertime, freezing, ready to get the heat back on. you know, they're very appreciative about it.
Sandy Cooper is a very good company. If this was my company, if it was me, I would have changed the name from Sandy Cooper to FC because it's a super company.
When we get power out calls, they'll tell us the names and we know exactly where they live because, you know, this is where we're from.
Approximately 2 million.
All right, so now we're switching over to transmission. These are going to be some transmission guys working here. You'll notice they usually lay out a tarp. It's a nice dry day over here, and they have what they call a stick trailer, and they've got their sticks out right here. You want to keep them in the trailer for two reasons. One is to keep them dry, and the other is so they don't get UV damage on the sticks. Sticks are very much taken care of in transmission.
People receive their power from Sandy Cooper.
That belt, see how long that brown strap is? That's a transmission climbing belt. It's got a huge, long brown belt so you can go around fatter poles.
South Carolina state-owned electric and water utility.
All right, this gives a good example right here. Now, this is energized. That's 115,000 volts. But the clearance away from the pole to where the conductor is sufficient for them to climb in between it. Now, what are they using to hold the conductor up in this location and push it away from the pole?
Using those sticks you were talking about.
Fiberglass sticks. There you go. Yep. See, he's got a fiberglass stick pushing it away, and this one here is to hold it up.
And it's the largest producer of electricity. Sandy Cooper's line technicians install, maintain, and repair power lines and equipment.
Okay, it just gives you a good example. I mean, it's intricate work. It is definitely more time consuming. Obviously, by the rigging and everything that you see are going on here, that conductor is now out of the insulators and is being held up by two fiberglass sticks and two sets of what they call jacks or hoists. And what they're doing here is actually an insulator replacement. Those insulators are probably right around 100 pounds worth of insulators right there. You'll notice, do they work as far as their work location? And this is what you learn in transmission. Is there any climber that's on this side of the pole closest to the conductor? This side?
No.
No, it puts you closer to the conductor. You don't want to be close to the conductor. You want to be off to the sides of it, okay? You want to maintain clearances.
In difficult weather conditions and at all hours of the day or night to keep reliable electricity flowing to our
That's legal. Okay, he's got a fall.
customers statewide.
He's got a fall rope right here behind him. In case he falls, it's connected to his belt. Plus he is belted around, and that's a brace for a cross arm upside down. That's perfectly legal.
Line technicians play a critical role in Sandy Cooper's mission to be the leading resource for improving the quality of life for the people of South Carolina. If you become a Sandy Cooper employee, you will join a team of proud professionals that has served the people of South Carolina for over 70.
Now it gives a good example right here. Now, I'll talk about this guy. I knew him well. You're working with 115,000 volts, okay? These are just regular leather gloves. Now, it's either leather gloves or barehanding is the technique. You're not going to wear rubber gloves here. You want to know if the stick starts breaking down, your hair will start standing up on your arms a little bit, or the stick will start to swell. You want to be able to feel that. Two, and this is probably, he's used to doing this, he's done this so many years, is a process of what they call short sticking. Now, what do I mean by short sticking? What's the distance between here and here? Maybe 3 or 4 feet, okay? Where he has a 10-foot stick. He's getting up to the range right here, and we've talked about this before. How many thousand volts per foot is this stick insulated for? Anybody remember? It's 100,000 volts per foot. All fiberglass products in the industry are insulated to 100 kV, 100,000 volts per foot. So if he's got 3 feet of insulation here, that's 300,000 volts, and he's working on a 115,000 volt line, he's okay. But he's getting in the short stick process right here. He's getting in the proximity of not using as much insulation as he can. Like I said before, there are multiple attachments that goes on sticks. You can put sockets, cutters, ratchets, all kinds of stuff.
5 years. To learn more, visit our website at www.santycooper.com.
Okay, that give you somewhat of an idea of what your question was about? Okay, good, good. All right,
11 o'clock.
that's 11 o'clock straight up. How about that? Great timing. All right, gentlemen, I need to, whoever has, maybe I can handle that out of the field. I know who my two people are. I'll get in touch with them and get them squared away out there in the field. Gentlemen, if there are no other questions here, we're going to go ahead and report out in the field at 12:30. Any questions? Have a good day. Drive safe.
All right. I'm gonna hit the road.
I'm going to look at the radar again real quick.
Okay.
Yeah, it's definitely moving in, but it looks like we got time.
Okay.
All right, man. See you in a little bit.
I'll see you out there.
Bye-bye.